In this lesson with factoring trinomials with the form ax squared plus bx plus c, we're going to be looking at the application side of it. We're still going to be dealing with perimeter, mainly area. It's just in this case, instead of finding the area like we were in the last lesson, you're going to be given the area, which means in order to undo that multiplication, we will have to divide to find the side lengths. So in this example, 3, it says the area of rectangle is given by the trinomial x squared minus 2x minus 35. What are the possible dimensions of the rectangle? Draw a model. So I will start by actually drawing the model. So I will put the x squared minus 2x minus 35 inside the rectangle because it represents the area inside the rectangle. We have been tasked to figure out the lengths, possible lengths of these sides, which pretty much means that when we have this formula of area equals length times width, we know the area now. We know that the area is x squared minus 2x minus 35. We have to figure out the two binomials that multiply to get that. In other words, we need to factor. So when I factor x squared minus 2x minus 35, a equals 1, b equals negative 2, and c equals negative 35. We need to list the factors of negative 35 and figure out the ones that add to get negative 2. The factors that multiply to get negative 35 but also add to get negative 2 are 5 and negative 7. So the dimensions are x plus 5 and x minus 7. To answer the next question down here, what is the perimeter of the rectangle? We must use our new side lengths, x plus 5 and x minus 7, to figure that out. So I'm going to shrink down the work from the area. We'll move up the work for the perimeter of the rectangle. Again, from our answer with the last problem, we figured out that this could be x plus 5. So this side is also x plus 5 because it's a rectangle. This side is x minus 7. And this side is x minus 7. And just like we did in the last lesson, we can do 2 times x plus 5 plus 2 times x minus 7. We simplify that expression with distribution and combining like terms to figure out the perimeter of our rectangle. The perimeter of our rectangle is 4x minus 4 units. In example 4, the area of your square card table is x squared plus 6x plus 9. So again, inside we have x squared plus 6x plus 9. It's a square card table, so I know all four sides should be the same. But again, the x squared plus 6x plus 9 represents the area inside the square card table. We're trying to figure out the possible dimensions, so that's the side lengths for the table. Now the fact that it's a square helps me with my drawing, but it doesn't change the fact that my area is still length times width. So I'm still trying to find those two binomials that would give me the x squared plus 6x plus 9. So in other words, again, I just need to factor this x squared plus 6x plus 9, where a equals 1, b equals 6, and c equals 9. The factors that multiply to get 9 but add to get 6 are 3 and 3. So my sides are x plus 3 times x plus 3. Now to use that for the perimeter of the card table in this second problem, it is helpful that it's a square because we just need to add the x plus 3 4 times, or we just do 4 times x plus 3. So the perimeter of the card table is 4x plus 12 units. Again, perimeter just has units. The area up here technically would be units, squared if I had my labels up there. This next example tries to trick us a little bit by talking about a parallelogram being given, the area of it is given as x squared plus 13x plus 36. Length and width of the shape, the parallelogram has 4 sides, so we are still dealing with the formula for area equals length times width. So the area is x squared plus 13x plus 36. And again, we're just finding the possible dimensions, so we need to factor. A equals 1, B equals 13, C equals 36. So the two factors that multiply to get 36 and add to get 13 are 4 and 9. So x plus 4 and x plus 9 are my length and width of that parallelogram. All right, example 6 is our first word problem, but you'll see that it's very similar, the information that's given to us. It says you are going to construct a chain link fence around your entire property. In accordance with the township ordinances, which means rules, there must be a 3 feet space between your fence and all edges of your property. So what I have shown here in this picture is the black rectangle would be your property. The red rectangle inside would be the fence, because your fence has to be 3 feet off of your property line. So the black is your property line, the red is the fence. So it says in part A that the area of your property, which I'll use black ink for this, from corner to corner is the x squared plus 20x plus 64. And we need to figure out the area of this enclosed portion. So what we're going to do first is we're going to use the area to figure out the length and width of our property and then take away 3 feet. The factors of 64 that also add to get to 20 are x plus 4 and x plus 16. Now comes a bit of the tricky part. What we have is that we have the edge of the black property. We'll make this x plus 4, since this looks like the shorter side. We'll make this x plus 6 because it's the longer side. So the issue is that in here, there's a distance of 3. In here, there's a distance of 3. So if I already have x plus 6, and I need to take away 3 twice to get to the length of this red side, we actually only end up with x. So this is going to be x length for the red rectangle. And the same thing happens for the horizontal distance. This is 3 and this is 3. So from the 4, I have to take away 3 twice, which is actually going to leave us with x minus 2. So our dimensions of our red rectangle are x minus 2 and x. And now that we have those dimensions of the red section, we can actually answer the question. It says if the area of your property corner to corner is that, what is the area of the enclosed portion? So now I can use that x minus 2 and the x, multiply those together to get the area inside, and it's actually just a quick distribution to get x squared minus 2x units squared. So this question was definitely a little bit tricky, so please make sure you watch this section of the video a few times to truly understand what we did when we were first using the given area to find the length of the big rectangle. Then we took the 3 feet space to figure out the dimensions of our smaller rectangle to ultimately answer the question of what the area was inside that smaller rectangle. We're going to use this area of the small rectangle and this area of the big rectangle in the next problem to figure out which, I guess about money, which area is larger by how much. So here we are at the part B. It says how many square feet do you lose by following the township ordinance? So what we're trying to figure out is how much space is in between that shaded section. So we're really trying to figure out the area in here, which is something that we did in the last lesson, actually 2 lessons ago. Well, the last lesson where we were finding the area of the shaded region. So we already have the area of the larger, that's what's in black, and we have the area of the smaller, what's in red, and we just need to subtract the two. We just have to be careful when we are doing that subtraction, as always, to make sure that we distribute that subtraction through. So our work, once we distribute the subtraction, we can drop that parentheses as long as we have negative x squared plus 2x. We're going to combine like terms to simplify. So when combining like terms, it looks like the x squareds cancel out. We're left with 22x plus 64 units squared. It is units squared because we are subtracting area. So that's the square feet that's lost in this space that does not get fenced in. So don't forget to watch this video as many times as you need in order to complete the application notes for 8.5. Thanks.